It's Techmath1. We're looking at chapter 9. So let's take a look at 9.1. That is in the blue book, and we're on page 375. So number 2 is they have V equals I times R, and I equals V divided by R. It says I varies directly as what? So here, from the rearranged formula, equals B R. So we would say I, this is the original one, V equals I R. I varies directly as blank, and I varies inversely. As blank. And so I would vary directly as V, and I would vary inversely as R. Because I and R, see, I is here, R is on the bottom, so that varies inversely. And I is on top, and V is on top, so that would be varies directly. All right. Lovely dovely. So formula rearrangement. This is when they're going to ask you to solve for a given formula. So here, let's look at number 8. It has y equals mx plus b. It's got, draw a box around each term. Okay. So all right, so they want us to box off the terms. So this is a term, this is a term, this is a term. So those are 3 different terms. Remember we thought of these as like unlike terms, things that couldn't be added or subtracted together. So this is a term, this is a term. All right. This is a term, this is a term, this is a term. We couldn't add any of those together if they were all on the same side of the equal sign. And so on this one, I don't entirely agree with the book here. They have D, and I'm with them on that. But this one, you really should do the distributive property and then call it 2 different terms. In your book, it just has it all as 1 term, and I think that's incorrect mathematically because you can't add those together. So, at a minimum, you should say, 1 term, 2 term, and then ignore the P. They just have 1 box around the whole thing. And so I disagree, respectfully disagree with that answer. All right. Okay. So, that was actually 9.2. 9.3 is, I want to do number 16. And they're going to probably have us solving different things there. They got V equals LWH. That looks like volume is length times width times height. And they want solve for L. So let's solve that for L. Well, what would we do? Well, we would divide both sides by WH. And then those cancel, and we get just L, and then is equal to V over WH. And that's it. So you just divide away anything that's being multiplied by the term. And so on the variable that you want to isolate and get a 1 in front of, you divide it away. All right. Let's look at 19. It has some interesting stuff. We got D squared FR equals M sub 1, M sub 2, and they want me to solve for F. So again, just like this one, we're just going to divide out anything that we're not adding or subtracting. There's no add or subtract. So we're just divide away D squared R, divide away D squared R. That R cancels, the D squareds cancel. We have just F, and then we're left with our answer. So M sub 1, M sub 2 over D squared R. Okay. And then there's a second one here. We got H is equal to 0.24 I squared R T. Okay, so again, and they want me to solve for R. That's a really sloppy R, sorry. There you go. So they want me to solve for R. So that means, again, we just divide away anything that's not R. 0.24 I squared T. 0.24 I squared T. And we're done. So these, I've had some students tell me that they think these are super easy because you don't actually have to divide anything, you know, you don't have to bust out your calculator. And I've heard some students say they're super hard because it's all letters, it's very abstract. And so I guess it depends on the student, whether you think those are difficult or easy. So let's do 9-4. That is 24. Let's jump to 24. And I have a feeling that is going to be a little bit more involved. We're going to solve. So it's AM is equal to C minus D over 2R, and they want me to solve for R. So we're going to go back to proportions. Remember how we do those? We put that over 1. We cross multiply and solve. So you have 2RM is equal to 1 times C minus D is just C minus D. And now, after we do that cross multiply step, it's just like the problem from before. So we're going to say, all right, I want R. So I'm going to divide both sides by 2M. And the 2's are going to cancel, the M's are going to cancel. I'm going to have just R, C minus D on the top over 2M on the bottom. And done. All right. Ooh, yeah, let's look at a couple more that are a little tricky here. Like number 30. 30 is a tricky one. So let's do 30. We got A is equal to 1/2 AT squared. That is tricky because it's sort of like it's over 2. We could do it like this, but that 1/2 really throws people off. They want me to solve for A. And so they want this solved out. What you could do is you could say this is like AT squared over 2. And then cross multiply and solve, just like what we did there. And so, wait a minute. Oh, this is an S, not an A. was going to say, how did they do that with 2 A's? There we go. I wrote down the wrong thing. Okay, so we cross multiply, we get 2s is equal to at squared, and then we divide the t squared out. And there it cancels, and that is our answer. So a is equal to 2s over t squared. All right, that's one way to do it. Another way to do it, and if you don't want to cross multiply like this, you can multiply by the reciprocal. So you could multiply 2 over 1, 2 over 1, you'll still get the 2s, and that'll cancel that away. And then you'll divide the t squared. So if you want to think of it that way, that's fine. Either way. All right. And okay, that was it for that one. Then let's look at 9(5), the square root principle. So when we're doing square roots, we're thinking of we're doing what number times itself gives you that number. So if I have v squared is equal to 2as, then if I want to solve for v, I would take the square root of both sides, but in algebra we throw a plus or minus in front of it. In this course, lots of times they just want the principal square root, which is just the positive version of it, because so many of our real life problems, oh wait, this was number 37, sorry, this is number 37 on page 385, all right? So the plus or minus is there. If it was a second degree thing, you should have 2 solutions for it, and there's how you would find them. But a lot of times, because these problems are entrenched in the real world, it's called a domain restriction, where x can't be negative a lot of the time with a lot of applied problems. And so this book, as a general rule, often just gives the positive answer, which is fine. And you can do that too. I won't take off credit if you do that. All right, and yeah, same thing here. If it was s squared is equal to a over h, algebraically, there are 2 answers. So you do the plus or minus the square root of a over h, and then, you know, because of a domain restriction, we throw away the negative and just say it's the square root of a over h. And that's it. But like I said, algebraically, I would be a real stickler about that you do the plus or minus. But in here, not so much. So let's take a look at application 44. Solve for P when we have CD over P equals PQ over A. Okay, so we cross multiply and solve. P squared Q is equal to CDA. And we divide both sides by Q. And now we have this. P squared is equal to CDA over Q. And then we do the square roots on both sides. And so that is P is equal to, again, I've been putting the plus or minus. I'm just not going to. CDA over Q. All right. It was plus or minus up there, but we threw it away because we were only interested in the positive. And make sure it's clear that the Q is also under the square root sign. My square root sign was a little shallow there where it could have been interpreted either way. So make sure you make it very clear that It's either in the square root or it's not in the square root. All right? Excellent.